are discussing about stride in the convolutional neural network. As we already discussed, when we are taking an input image 7 by 7 and when we are considering a filter 3 by 3, we will get a feature map matrix 7 minus 3 plus 1, which is nothing but 5 by 5 matrix. But now we are introducing a new concept. First, when we applied the filter, 3 by 3 filter, we are applying to this particular image patch. And we have got example 91 is the result. Again, we have to apply, we have to shift by 1 pixel and we have to apply to this next second image patch, a small patch. I am calling a 3 by 3 matrix, image pixel matrix as a small patch. But instead of applying the filter to this patch, I am skipping 1 pixel and I am applying the filter to this image patch. Then we are saying the stride for this convolution is 2. Why we are saying 2? Because after the application of the filter to this particular patch, we are shifting 2 pixels. That's why we are calling this is a strided convolution with stride 2. And similarly, after the completion, we will also shift 2 rows when we shift to the row wise. This is how we will go. We will see the animation in order to understand it. This is what we have discussed. Now, the filter is applied to this particular image patch. So stride is 2. Again, after the filter is applied to this image patch. This is like I am showing at a glance. First, we have applied the filter to this patch, and then immediately we are shifting by 2 pixels, so it is stride 2. Again, we are shifting by 2 pixels, so it is stride 2. Similarly, we are shifting row wise 2 pixels because it is stride 2. Similarly, we will shift until the last black. So we are getting a feature map of 3 by 3. It is reduced from 5 by 5 to 3 by 3. If we are using stride 1 by 1, then we are getting 5 by 5. But when we are using the stride 2, we are getting a 3 by 3 feature map matrix. In order to calculate what is the size of the feature map when we are including the stride, then we are changing this n plus 2p minus f a little bit by dividing with the stride s. So n plus 2p minus f division with s plus 1 is giving the feature map matrix size. As we already discussed, when we do not have any filter, then it is n minus f plus 1. Sorry, when we do not use the padding, then it is n minus f plus 1. When we implement the padding, then we are adding plus 2p. And when we are implementing the stride, then it is n minus n plus 2p minus f by s plus 1. The only difference is we are dividing with respect to s and adding plus 1. We will check in this case. N is 7 plus 2p. We have not added any padding here. So this is valid padding. No padding means valid. 7 plus 0 minus f. F is 3. By stride is 2 plus 1. So 7 minus 3, 4. 4 by 2, 2. 2 plus 1 is equal to 3. So you can observe the feature map matrix size is 3. You can observe here how the strided convolution is happening with a stride 2. We have taken an input image of 7 by 7 and we have applied a kernel 3 by 3. Because we are using a stride 2, so n minus, when we apply the concept, n minus n plus 2p minus f by s plus 1. Here n is 7 plus 2p. 2p means 0 minus f is 3. Stride is 2 plus 1. So it is 4 by 2, 2, 2 plus 1, 3. So we are getting a 3 by 3 feature map. Now you will see that is now you see the result. Here we have applied padding also. So n plus 2p minus f by s plus 1. So n is 5 by 5 matrix. So n is 5 plus 2p 2, because padding we have added outermost one layer, and f filter size is 3. This is the filter 0 0 2 0 1 1 0 0 0 1 1. That is the filter. So filter size is 3 by 3, and stride we are taking a stride 2 plus 1. So the result equal to 5 plus 2 7, 7 minus 3 4, 4 by 2 means 2, 2 plus 1 3. So the final output feature matrix is 3. This is how strided convolution is happening with padding. This time we have considered padding. So padding is equal to, we have considered the padding, but this time, even though we have considered the padding, the feature output of the feature matrix, output matrix or feature map matrix size is not same as the input. Even though we have included the padding, because we have included the strided convolution, output size is not same as the input image size. So summary is, when we have an n by n image and f by f filter, padding is p and stride s, then the feature map size is n plus 2p minus f by s plus 1 by n plus 2p minus f by s plus 1. Now in the Kanu 2D layer of Keras, we have considered stride 1 by 1. Because stride is 1 by 1, as we discussed, input image size is 28, n plus 2p. We have not considered padding, so p is 0 minus f filter size is 3 by s, because stride is 1. 1 by 1 stride means even without applying this 1 by 1, without even including this also, it will not matter anything. So 28 minus 3. 1 by 1 slide means we are shifting 1 by 1 pixels, pixel by pixel. 28 minus 3, 25 plus 1, 26. That's why you can see here output feature map shape is 26 by 26, and we are having 64 such feature maps. So total number of parameters 640. Now we are changing the stride. I am changing the stride to 2 by 2. Now you see, because I have changed the stride to 2 by 2, here I have to take 2. Now 28 minus 3, 25. 25 by 2, integer division, it calculates as 12. 12 plus 1, now 13. Previously it was 26, so now it is 13. You can observe 13 by 13 with 6. If I use stride 3, then 28 minus 3, 25. 25 by 3 means 8. 8 plus 1, 9. I will get 9. We will see about it. So I am taking the slide 3 by 3 and I am executing. So you observe the same 9 by 9 we got. The feature map, output feature map size is 9 by 9, and we are having 64 such feature maps. Now we are including the padding. I have included the padding as same. So n is equal to 28 and 2p. Padding I have included 2 into 1, 2, and filter size is 3, and stride is 2. So 28 plus 2, 30, 30 minus 3, 27, 27 by 2, 13.5, but integer division, so it is 13, 13 plus 1, 14. Now you observe here, it is 14 by 14, and we are having 64 such feature maps. Now instead of considering stride 2 by 2, we will change to stride 3 by 3. And we change the stride to 3 by 3, then it will become 28 plus 2 minus 3 by 3. So it is 30 minus 3, 27. 27 by 3, 9. 9 plus 1 is equal to 10. So in this case, it will become 10. We will check. So I'm changing stride 3 by 3. We're executing this one. Now you observe. This is 10 by 10 as we got the 10 result. So feature map is 10 by 10 and we are having 64 such feature maps. Now we want to change the kernel size to 5. So I am considering this as 5 by 5. When kernel size is 5, the padding P is equal to F minus 1 by 2, means 5 minus 1 by 2 is equal to 2. So here n plus 2 into 2, 4. So n 28 plus 4 minus 5 by we are taking the stride 3. Let us consider we are taking 3. So plus 1. This is equal to 32, 27, 9 plus 1, 10. Again, we should get 10. We will execute this one. See, again, we got the 10. 10 and parameter 64, 1664. This is indicating that we have 10 by 10 feature map. But for getting the 10 by 10 feature map, how many filters we are taking? We are taking 64 filters. So 64 into 5. What is the filter size? 64, 5 by 5. 64 into 5 by 5 plus 64. This is the bias value we are adding for each filter. This value is giving 1664 parameters. Okay, these 1664 parameters update every time. For every training sample we are giving, this will be updated based on the error or based on the loss we are getting. The update will be done. Okay, now instead of considering stride 3, we will consider the stride 2. So when we consider the stride 2 here, 28 plus 4, 32, 32, 27 by 2, 13, 13 plus 1, 14. We should get the value 14 here. We will see that. So when we are taking stride 2, so we are getting 14. This is how, when we are changing the stride, when we are using the strided convolution, we will observe a reduction in the output matrix size of a feature map.